begin. Now, what is a rate of reaction? Now, if you see any reaction, it has reactants and products. What happens to the reactants with time is that their concentration starts to fall. And on the other hand, the product's concentration starts to build up. So this is the graph. The blue graph is of the products, and this red graph is showing us the reactants, that the level of the reactants is decreasing with time and the products is being built up. So in order to measure the rate of the reaction, what we can do, we can use the change in concentration of the reactants and the product. So rate of the reaction is concentration of product increase with time or decrease in the concentration of reactants with time. Now, how we can measure the concentration of the reactants or the product? Now, it depends on what kind of a reaction we are taking. So if the reaction involves a solid reactants, we can weigh the mass of the reactants at different time intervals and plot the graph, and we'll get a shape of the graph something like this, sloping downwards because the reactants decreases with time. On the other hand, if there's any reaction that involves gases, we can measure the volumes of gases evolved at different times intervals, and we'll see that the graph looks like this, where volume of gases increases with time. And if there's any reaction that has a precipitate being formed, then we can measure the concentration of this precipitate by using a spectrophotometer and measuring the absorbance value. So these are the various ways in which we can measure and plot the rate of the reaction. And for any of these graphs, we can draw a tangent and then find the difference in the y and the x axes to find the rate of the reaction. Now, the question is why we are studying the rate of reaction. We are studying rate of reaction because they are very important reaction industrially. For them, we want a greater rate so that we can make more money and more profit, and they are very useful to the mankind. So for them, it's very necessary for us to understand what factors affects the rate of the reaction and how we can alter them to increase the rate of reaction. So the factors that affects rate of reaction can be explained with the help of collision theory. Now, collision theory states that, remember, it's very important because any factor that is affecting rate of reaction comes in the exam, you need to answer about the collision theory. So collision theory has three parts. It says that for a reaction to take place, we require collision, and the particles should collide for the reaction to take place. And it's not just bumping into each other that will make up the reaction faster. All the particles should collide with the minimum energy required to start the reaction, called the activation energy. So the collisions which have energy equal to or greater than the activation energy is the successful collision. So we first want collision, then we want successful collision with the energy greater than the activation energy. And apart from collisions and the activation energy, proper orientations of the reactants is also required for the reaction to take place. So what are the factors that can now affect the rate of reaction? That are surface area, temperature, concentration of reactants, pressure, and catalyst. Now we'll answer all these effects and explanation on the basis of collision theory. Now you can see low concentration, fewer collision, higher concentration, more particles to bump into each other, greater the rate of reaction. So we'll discuss the first factor, how the concentration affects the rate of the reaction. So for the concentration to affect rate of the reaction, what we need to do, when we increase the concentration, the rate of the reaction increases. Now, why it increases? Because there are more particles, more collisions, more collision, more the chances of successful collision, and greater the rate of reaction. Okay, so if this question comes in the exam, how concentration of reactant reaches the rate of reaction, make sure you explain the collision theory, that for the reaction to occur, we require collisions and successful collision. So if there are more particles, there'll be more chances of collisions and more chances of successful collision, increasing the rate of reaction. In the similar way, when you talk about surface area, when you increase the surface area or surface area to volume ratio, the reactants are very exposed to each other. So more the exposures of the reactants to each other, more will be the collisions, and more chances of collision increase the rate of reaction. So that is why it says that rather than taking a zinc mass or any reactant mass, you take a lumps of it or powdered reactant, because when you do it in a powdered form, you're increasing the surface area to volume ratio, so there are more chances of the reaction to take place. Now, when we talk about temperature, temperature does two things. First of all, it makes the particles gain kinetic energy, so they collide or bump into each other more frequently. Secondly, as the kinetic energy increases, the energy of the particle increases, so there are chances that more particles now have energy equal to or greater than the activation energy, increasing the rate of reaction. So remember, temperature does two effects: increasing the frequency of collision and increasing the energy for collision. Next is pressure. Now, pressure only holds true for the gaseous reactants. When you increase the pressure, it increases the rate of reaction, as there will be more particles in a lesser volume. So when you increase the pressure, what you do, we squeeze something. When you squeeze it, so the particles squash, so they collide more, they bump into each other more, and more the collision, more is the rate of reaction. Now, what does catalyst do? This is very important. You should be able to explain it graphically. That we'll be doing next. With the use of catalyst, the rate of reaction increases. How? This is for the second part of the collision theory, that catalyst provides an alternative route to a reaction that lowers the activation energy. Now, as the activation energy of the reaction is lowered, now you have the more number of particles having the energy equal to the activation energy, increasing the rate of reaction. Okay, so I hope all these factors are clear to you, and in all these factors, do not forget to take the name of collision theory, and if possible, explain this theory first and then come to the explanation of all these effects. Okay, in that case, you will never lose a mark. Okay, so now let's see how catalysts work. Now, the properties of the catalyst said it is required in small quantities, regenerated after the reaction. They increases the rate of reaction by providing an alternative route. An alternative route lowers the activation energy. As the activation energy is lower, there are more number of particles having energy equal to or greater than the activation energy, increasing the rate of reaction. Example, iron in the Habeas process, nitrogen and hydrogen forms ammonia. There we use iron as a catalyst. And nickel is used in a hydrogenation of alkene. Ethene plus hydrogen in the presence of nickel catalyst forms an ethane. Now, catalysts help those reactions that requires a very high temperature or high pressure to be successful at a lower or the moderate temperature and pressure. So it helps us to save a lot of electricity and energy cost, and helps us to prevent the greenhouse emissions or the fossil fuels emission by lowering the energy cost. So it's good and safer for the environment to use the catalyst. Now, this is a very important graph that you should remember. If you remember, in the energy changes, we drew this reaction profile diagram, that we have this energy, and this is a reaction coordinate, or you can write progress of a reaction. The reactants and the products are at a lower energy level, and there's a bump, and that bump is the activation energy without a catalyst. But when you do a catalyst, the reactants and the products remains at the same level, just this bump decreases. Here it says enzymes. Enzymes are biological catalysts, so you can write in the exam with catalyst. So with and without catalyst, you can see the bump is lowered, so the activation energy is lowered, so the reaction is possible at a lower temperature, increasing the rate of reaction. Okay, so I hope this is clear to you. Now, that finishes the rate topic, and now let's start with the equilibrium topic. Now, what is an equilibrium? To define an equilibrium, we should first know what is a reversible reaction. Now, there are many reactions in chemistry which are reversible. Reversible means reaction that proceeds both directions, that is the forward and the reverse. For example, manufacture of ammonia by a Habeas process. So nitrogen plus hydrogen gives ammonia in the forward direction, and in the reverse direction, the ammonia breaks up to give nitrogen and hydrogen. Now, how this reaction starts? You can see at the start, the reactant's concentration decreases and the product concentration increases. As the reactant is decreasing with time, the product is increasing with time. Now, at this point, can you see the concentration of both the reactants and the product is same? Why? Because at this point, the rate of appearance of product and the rate of disappearance of reactants is the same, and this is known as equilibrium. Now remember, do not write same in equilibrium. Equilibrium has a proper definition, and you need to write exactly like this. Equilibrium is when the rate of forward reaction is equal to the rate of reverse reaction. Now, most of the students think that as the concentration doesn't change at equilibrium, the reaction stops at equilibrium. But this is not true. The equilibrium is dynamic. What is dynamic equilibrium? It means that the reaction does not stop at equilibrium. The reaction takes place with the same rate in both the direction. So overall, we see no change. And for the dynamic equilibrium to set up, it has to be a closed system. So nothing should leave or enter the system, and the rate of forward reaction should be equal to the rate of reverse reaction. Okay, so I hope the definition of equilibrium is clear to you. Now, why we are studying equilibrium? So that we can alter equilibrium. And how we can alter equilibrium? By this Le-Chatelier principle. Now, first of all, remember the definition and always write in the same way. When the system in equilibrium is subject to a change, the equilibrium is moved to a direction to counteract the change. Now, what does that mean? For example, you're doing a reaction and you are deliberately increasing any concentration. So the reaction will move into that direction where that particular concentration that you have increased can be decreased. Got it? Confusing. Okay, let's take an example. Just see this reaction. This is the ammonia manufactures where nitrogen and hydrogen gives ammonia. So in the forward direction, what is happening? That is to the right, ammonia is being made and nitrogen and hydrogens are getting used up. In the reverse direction, what is happening? Ammonia is used up and nitrogen and hydrogen is made. Now, if you add nitrogen deliberately to this system, according to the Le-Chatelier principle, whatever you do, the reaction will do the opposite. So you have added nitrogen, the reaction will move to that side, which is using up the nitrogen. So what is that side? Right. So the equilibrium will shift towards the right by adding nitrogen. Similarly, when you add the hydrogen, again, the equilibrium will try to decrease hydrogen. So it will move to that side that will decrease hydrogen, which is the right side. I hope you are getting it now. Let's take ammonia. If you add ammonia, according to Le-Chatelier's principle, what will the system do? It will try to decrease ammonia. Decrease ammonia means move to that side, which is using up ammonia. So the equilibrium will shift towards the left. On the other hand, if you remove ammonia deliberately, the system will require to move to that side, which will make up ammonia. So the equilibrium will shift towards right. So in Haber's process, nitrogen and hydrogen are continuously added and unreacted or recycled, and ammonia is removed as soon as it is formed, so that we always have the reaction shifted towards right and higher yield of ammonia. Okay, so remember this principle, and if you do the question exactly the way I'm telling, you will never ever make a mistake. So see what factor you're changing, and then what is the counter of that factor and which direction it is happening. Okay, let's take another example, pressure. Now for the pressure, there's a rule. More the gas molecules, more the pressure, less the gas molecules, less the pressure. So in this side, more pressure is onto the left side because it has 4 moles of gases, and less pressure is on the right side. So if you increase the pressure, what will the system do according to Le-Chatelier's? It will move the reaction to the less pressure side. And which is the less pressure side? To the right. On the other hand, if you decrease the pressure, the system will do the opposite. It will increase the pressure, so move the reaction to the more gas side, which is the left. So high pressure is required for the manufacture of ammonia. Okay, so I hope this is clear to you. Similarly, the temperature has the same effect, but for the temperature, you need to remember a rule. If a forward reaction is exothermic, that is producing heat, then the reverse will be endothermic, that is taking in heat, and vice versa. An exothermic reaction is the one that produces heat, endothermic takes in heat. How will you come to know whether a reaction is exothermic or endothermic? You look at the delta H sign. If the delta H is negative, the forward reaction is exothermic. And if it is positive, it is endothermic. So in this equation, the forward reaction is producing heat. So if you increase the temperature, the reaction will move to the side that will decrease the temperature, that is to the endothermic side, which is the left, and decrease in temperature will shift the react to the more heat side, which is to the right. Okay, so for manufacture of ammonia, we require a low temperature. Okay, so I hope all these effects of equilibrium and rates of the reactions are clear to you. Now you should be able to define rate of reaction, collision theory, activation energy, catalyst, reversible reaction, dynamic equilibrium, Lee-Shuttle's principle, exothermic and endothermic. Okay, pause this video, have a go over these answers. If you still cannot answer them, go back, watch the video again. All these answers can be found on my website. The link is mentioned in the description box below. As always, our next step, as I always insist, do check your specification. Make sure whatever thing is there in your specification is crystal clear to you, and do exam questions on this topic, which can be found on my website. Now, please do not forget to subscribe to my channel and click on the bell icon, which is just to the right, so that you can get notified as soon as I put a new video. If you have any doubts in any of this topic, leave a comment below and I'll try to reply you as soon as possible. Or else you can come to my website where I'm available 24/7 on chat before your exam to answer all your queries. Okay, so I'll see you next in the next video. And if there's any specific topic you're finding hard and you want me to put a video on, then also leave a comment below and I'll make sure I'll have that up and running before your exam. So I'll see you next in the next video. Till then, happy revising.